amplitude modulation. So in the previous discussion, we have defined the different equations for the different signal waveforms. So for a modulating signal, the equation will be E sub m is equal to EM is the amplitude, sine omega mt. For the carrier signal, we denote that as E sub c be equal to EC sine omega ct. And for the modulated signal, we denote that as EAM equal to EC plus EM sine omega mt. So this is the amplitude of the modulated signal, and then multiplied by sine omega ct. This is the frequency of the modulating signal, which follows the frequency of the carrier signal. Now let us define some equations from the modulated signal waveform and equation. So, equation nito is EAM is equal to EC plus EM sine omega mt multiplied by sine omega ct. So again, if we look at our graph, so from our previous discussion, the zero reference line of the modulating signal coincides with the peak value of the unmodulated carrier. That means that the peak value of the carrier, ito, is the reference point for the modulating signal. So, paano ngayon natin makukuha si E maximum? So, how do we compute for the E maximum here? Or for the maximum amplitude of the modulated signal? So, let us denote this as E maximum, and dito naman sa baba will be your E minimum. And in getting the value for your E maximum, the formula will be EC plus EM. For E minimum naman, the formula will be EC minus EM. Okay? So, from the equation, we have si EC plus EM sine omega mt sine omega ct. Yung amplitude natin dito is ito. So, let us write it here. EC plus EM sine omega mt. So, let us denote this as our equation 1. Now, if EM is greater than EC, distortion would occur. So, this leads to the definition of the modulating index, which is represented by the letter M. So, yung modulation index natin, represented by letter M, and we will discuss modulation index further later on. So, yung modulation index natin is equal to EM over EC. Ito yung definition ng modulation index natin. Now, kung gusto nating i-write yung ating amplitude dito sa equation number 1, let us then manipulate yung equation ng modulation index natin. For example, we are going to have a substitute for EM here from the formula of the modulation index. So, if we are going to manipulate this one, we will have an equation for EM equal to MEC. So, ito ngayon yung pwede nating i-substitute dito sa ating formula number 1. So, let us denote this as formula or equation number 2. Now, we are going to substitute equation number 2 to equation number 1. So, our A will be equal to EC plus MEC sine omega mt. So, ito na ngayon yung bagong amplitude natin for the modulated signal. And if we are going to substitute this one to the original equation, we will now have a new equation for our modulating index, modulated signal, I should say, be equal to the new amplitude EC plus MEC sine omega mt multiplied by the frequency sine omega ct. So, ito na ngayon yung bagong formula ng ating modulated signal. But let us further distribute si sine omega ct dito sa ating amplitude. So, ang mangyayari dito, we will have an equation of the modulated signal be equal to EC sine omega ct plus MEC sine omega mt sine omega ct. Okay? So, to simplify this one, we are going to use a trigonometric identity, which is this one. Sine x multiplied by sine y is equal to 1/2 multiplied by cosine x minus y minus cosine x plus y. So, this is only a trigonometric identity for sine x, sine y. So, since x and y yung ginamit natin dito and yung variable natin dito is w sub ct and w sub mt. So, let us denote x as w ct and y as w sub mt. So, sa next slide na. So, let x be equal to omega sine o omega ct or omega sub ct and y be equal to omega sub mt. So, if we rewrite yung ating equation for the amplitude modulated signal, we have EAM is equal to EC sine omega ct. Ito, yung x and y natin is only applicable dito sa inapplyan natin ng trigonometric identity, which is on the second function. So, this will be equal to plus MEC multiplied by, then ngayon, papasok na ngayon dito yung ating trigonometric identity. So, si x natin will be double omega ct, si y natin is omega mt. So, mangyayari dito, it will have 1/2 multiplied by cosine omega ct minus omega mt and then minus cosine omega ct plus omega mt. Now, let us recall the formula for omega. So, yung omega natin is equal to 2 pi f. Therefore, yung omega sub c natin will be equal to 2 pi fc. Yung omega sub m natin will be equal to 2 pi f sub m. Okay, so ito ngayon is substitute natin dito sa mga values of omega. So, we now have value for EAM be equal to EC sine. Okay, meron tayong omega sub c dito. So, palitan natin siya with 2 pi fc. So, magiging sine 2 pi f sub ct plus MEC multiplied by, or guys, i-factor out na lang natin si 1/2. So, that will be equal to 1/2 MEC multiplied by cosine. Okay? Si omega ct natin, meron na naman tayong omega. So, palitan natin siya ng 2 pi f sub ct minus omega m. Omega sub m, 2 pi f sub m. So, 2 pi f sub mt minus cosine 2 pi f sub ct plus 2 pi f sub mt. Okay? So, let us further simplify. So, since common sa kanila si 2 pi, pwede natin siyang i-factor out. So, mangyayari dito, we will have EAM be equal to EC sine 2 pi FCT plus 1/2 MEC multiplied by cosine 2 pi times F sub C minus F sub M T minus cosine 2 pi multiplied by your F sub C plus F sub M T. Okay? So, looking at this equation, yung first part ng equation natin is the carrier. So, ito ngayon yung carrier natin. The second part, if we are going to further simplify, okay? So, let us further simplify. So, si EAM will be equal to EC sine 2 pi F sub CT plus, eto, si 1 half MEC, i-distribute natin sa kanila. So, ang mangyayari dito, we will have MEC over 2 times cosine 2 pi FC minus FMT minus MEC over 2 cosine 2 pi FC plus FM times T. So, again, yung first part ng equation natin is the carrier. The second part is the lower sideband kasi meron tayong FC minus FM dito. And the third part is the upper sideband kasi meron tayong FC plus FM. So, we can say that by algebraically adding the carrier and the two sidebands, si lower sideband and upper sideband, signals together, the standard AM waveform described earlier is obtained. So, this equation is a solid proof that yung AM wave natin contains not only the carrier but also the sideband frequencies. So, observing an AM signal on an oscilloscope, makikita mo lang doon is amplitude variations of the carrier with respect to time. So, ang tawag natin sa frequency sa display na yon is the time domain display. So, for example ng time domain display natin is this one. So, with respect to time siya. And this is your amplitude. So, this is an example of a time domain display. It gives no indication of the existence of the sidebands. So, pag tinitingnan mo yung waveform na to, wala kang makikitang indication na meron siyang sidebands. Although, in the modulation process, it indeed produces a sideband or it indeed produces the two sidebands. So, there is another method of showing the sideband signals. It is by plotting the carrier and the sideband amplitudes with respect to frequency. So, ang tawag naman natin dito is the frequency domain display of an AM signal. So, how do we do that? How do we represent an AM wave by using the frequency domain? So, we have a graph here. This is frequency. With respect to frequency naman tayo. And yung ating ito is the amplitude. So, for example, meron tayong ito si EC, si carrier signal natin. We can represent the two sidebands here. This is the LSB or the lower sideband. And this is the upper sideband. So, this is LSB, the lower sideband, and USB, the upper sideband. So, ano ngayon yung amplitude ng ating lower sideband? So, from the equation na na-form natin kanina, we have the equation for the lower sideband is MEC over 2 cosine 2 pi FC minus FM times T. So, if we observe dito sa ating equation, yung amplitude natin is CMEC over 2. So, that is the amplitude of the lower sideband. And of course, yun din yung amplitude ng ating upper sideband. Now, how do we know kung ano yung frequency na gagamitin natin for this signals. So, yung frequency ng EC natin, ng carrier signal natin, is of course, F sub C. How about sa lower sideband and upper sideband natin? Ito yung frequency ng ating carrier signal. How about naman sa lower sideband and upper sideband natin? So, we have si FC minus FM for the lower sideband and FC plus FM for the upper sideband. So, that is how you compute for the sidebands and the carrier frequency. So, yung lower sideband natin is FC minus FM. Upper sideband is FC plus FM. So, those are the different equations na nakuha natin from the modulated signal waveform na magagamit in the computation of analog modulated problems.